All right, so here we're asked to find the sum of this particular sequence from 1 to 5. And first of all, we want to notice this is geometric because it's of the form a times r to the k minus 1. It's k in this case because this has a k. And we want to add up the first 5 terms, 1, 2, 3, 4, and stop at 5. Now we could write them out and add them up, but if we wanted to go from 1 to 50, I don't want to add up 50 fractions. It'd take forever. So there's a little formula. This is called the nth partial sum. So in this case, it's the 5th partial sum because we're adding up the first 5 terms. And that's called in general, it's the nth partial sum. For us, it's going to be the 5th partial sum. And this is our little formula. So we just plug it in. So in this case, it's the 5th partial sum because that's where we're stopping. And what is the 5th? It's a. A is the coefficient of what's raised to our power. A is 3. And then we have 1 minus r to the n. R is 1/2 because that's what's raised to the k minus 1. 1/2 to the n. Well, n in this case is 5 because that's where we're stopping. Over 1 minus r again is 1/2. And now we just do the arithmetic. So this is 3, 1 minus 2 to the 5th is 32, so we get 1 over 32. 1 minus 1/2 is 1/2. Think of 1 as 32 over 32. 32 minus 1 is 31 over 32. So we get 31 over 32 divided by 1/2. Our rule for dividing fractions, this divided by this, we invert and multiply. So this is 3 times 31 over 2, 31 over 32. We're going to invert and multiply, so we invert and multiply, we get this. Simplifying, 2 goes into 32 16 times. 3 times 31 is 93, so we get 93 over 16. And that's what we get. If I were to write out the first 5 terms, plug in 1, we get 3. Plug in 2, we get 3 times 1/2 or 3/2. Plug in 3, we get 3 times 1/4 or 3/4. And add those up. This is what the sum of the first 5 terms would add up to. So that's how we do what's called nth partial sums.